All right, good morning, everybody. So I'm here today to talk a little bit about how our planning for Artemis is focusing on enabling science. I do want to start out by noting one big change that we had lately in our directorate was that Dr. Lori Glaze joined ESDMD on detail as our Deputy Associate Administrator. She'll be here tomorrow. She probably won't brag about herself or her role, so I'll do it real quick. For me personally, it's great to have another scientist up at a high level in management in the exploration directorate. I think it does hopefully demonstrate the level of integration that we're trying to achieve between our directorates. And Greg talks a lot about feeling that it's unprecedented, the level of interaction we're seeing between what we used to call stovepipes, but now we have routine meetings set up to interface. So Sarah and Deborah and I, sometimes it's hard to tell if we're actually in the same directorate or not. We aren't, but we do interface daily, even hourly, some days. So I did want to just highlight that, and looking forward to hearing from Lori and Gina as well tomorrow. You've probably seen this slide before, and if not, I do want to highlight. I'll talk about our architecture strategy. So how are we working together to develop the plan for exploring the moon? As our top level NASA management, Pam Melroy likes to say, building the blueprint for exploring space. There's a lot of ways you can try to highlight this. This is the way that we're doing it right now. We've been talking about our pillars that hold up the value of our exploration. We refer to those pillars as science, inspiration, and national posture. I spoke with the PAC about this 2 weeks ago. We showed this slide, and I talked with the suppliers conference, the Artemis suppliers conference, a little while ago about this, and I was tasked on explaining to our suppliers, the companies that we're contracting with, what the point of the science circle is. And so I started off by just saying, I think most of us know what we mean by inspiration. Just this morning, our survey leaders met with our early career folks, and I can say that they are an inspiration to us. They help us keep moving. Why would we do any of this if there's not someone to hand this off to in the next generation? But it also talks about careers and establishing folks to do this work in the future, to be inspired to go into STEM careers. I think national posture is probably one that folks to some degree understand. I mean, this is us doing the work that we do so that we can build partnerships globally, look for ways to partner. And it's another piece of this that really holds up what we do. How are we projecting our efforts so that we can partner with each other globally? And then I think I don't need to explain to this community what the science is, right? This is the part that you understand, but I want you to see that it is an integrated part of what we're talking about. And I know in light of the conversation we just had this morning, there's questions where you're not going and making those measurements. And again, I'll talk a little bit about this as we go through here, but it's not that we don't want the measurements. It's not that we see no value in them, but we have to set up the architecture so that we can keep this going. We don't want to set something up that pushes us off to the right so that we don't get that foothold. And again, I'll bring that up as we go forward. But the science, I like to talk about the part that's not in the overlap in the Venn diagram. That's like the things we want to go do, right? All the research that you want to go accomplish. But there's also the research we've already done that is kind of the applied part that helps us understand how to build the architecture. So there's kind of two flavors to the science part, and I just wanted to highlight that. So how are we using what we're doing to set up the architecture? And the purpose of this presentation today, just like Sarah's presentation, is to help you understand what's happening and to help you understand how and where you can become involved. So we've gone through a little bit of a paradigm shift over the last 2 years or so. And one way to say this is that we're actually setting this up as a systems engineering approach. Okay, we're starting with objectives, and we're trying to use those objectives to drive out the steps that we need to take. So in this slide, we kind of focus on the goals and the objectives. So early or late 2021 and throughout the year 2022, NASA spent a good bit of effort interfacing internally, interfacing with academia, with industry, and our international partners and other areas of the US government to identify what are the objectives that a broad community hopes to achieve by sending astronauts and robots to the moon and eventually to other destinations like Mars and farther into the solar system. So we collected that input and consolidated that and identified a set of goals and objectives that are now referred to as the Moon to Mars objectives. And I'll walk through what the content in the middle of the box, the recurring tenets, but it's important to note that there are 4 major areas of objectives. And so that's another thing to be really clear about. Science is a major driver, but it's part of a broader spectrum of objectives that we are trying to accomplish with a very broad and diverse community. So to focus in on the objectives, have a QR code here. I would encourage you to take a look at this document because you have to understand what are the drivers that we are trying to trace to. This is the content that was brought together from that effort in 2022. And it gives us the starting point. This is what we trace to. Again, we're kind of looking at it's a document that maintains a systems engineering approach to crewed deep space exploration. And what's different now, the paradigm changes that we're looking to this as the starting point instead of building capabilities and then trying to determine how we'll use them. What I told the pack was, I really hope that I never have to go talk to Sarah and Deborah again and say, hey, here's the next thing we're going to build. Tell us how it achieves your science, right? We can't do it that way. We have to start with what they want to accomplish, what all of our stakeholders want to accomplish, so we can make informed choices about what the right next thing to do is. So just some highlights to this, this objectives-based approach, we're trying to drive ourselves towards enhanced communication and engagement. So I'll talk about how this documentation is being made public, and we are talking internally. I mentioned it earlier, this integration inside NASA so that our directorates are having conversations with each other. And Sarah just talked about all these activities that you can participate in. The intent of all the activities that she mentioned are to drive out documentation that you contribute to, that the Science Mission Directorate can then use to trace to as they're building the strategy with us. Okay, so I do want to be really clear about why those things are important, why the Lunar Surface Science Workshop documents are important, why the Academy studies are important. These are the things that they will look to as they work with us and the other directorates to develop the strategy for this architecture. Recurring tenants was one of the boxes inside the objectives. So what this really means is these are basically fundamentals that need to be present regardless of the objectives that you're talking about. So we bin the objectives into different groups, of which science is one. But these are things that were common across all the objective sets. So, crew time, top center there, that's something that all of the objectives groups indicated they needed to have. So we didn't want to talk about crew time in each one of them. That's a recurring tenet. It's something like an underlying principle we need to have as part of this architecture. Again, you can go through that document and find this and read about it in more detail, but I just wanted to highlight here what these are. We also have a set of exploration objectives: lunar and Mars infrastructure, transportation and habitation, and then the operations that we need to conduct in space. Many of these are linked to achieving the other objectives that are science-focused. But again, this is where I kind of earlier this morning talked a little bit about getting that foothold. These are some of the things that we need to get in place on the lunar surface so that we can realize the more difficult or more complicated or more grand science objectives that we'll have in the future. We need these other objectives to mature along with the science objectives as we proceed. The science objectives, just kind of showing how they break down, probably makes sense, but lunar and planetary science, heliophysics, human and biological science, the physics and physical science. There's science enabling goals, so things that need to happen, objectives that need to be met to help us enable the science we want to do. And then the applied science, as I talked a little bit about earlier, the knowledge we'll gain so that it helps inform us how to make choices about the architecture. So again, I just want to be clear, even within the science objectives, It's a broad spectrum, and there are many things that we're taking into account that we need to achieve through the Artemis architecture that we're developing. I just put this in here to give a little bit of detail, so you can download these slides afterwards and look at them. You can also go look at this. SMD has shown a number of presentations that you can show very good traceability between these and decadal objectives, right? So this wasn't a bunch of people going into a back room at headquarters and kind of just deciding what science we're doing. And this is why everything that Sarah talked about is so important. We need that traceability from the existing documentation that you're working that anchors what we put into the architecture. Now, once we have those objectives, we go through a process of breaking those objectives down into what I like to call actionable items for our engineers. So from an objective, we can break it into what we call a series of characteristics and needs. So these are our features, activities, the capabilities that we would need to be able to meet those objectives. From there, we can break it down further into what we call use cases. So, what do we need to go do in order to meet and achieve those characteristics and needs? And then functions, which are the kind of the specific things. So you start at an objective like uncover the history of the solar system. What does that actually mean? This process helps us break that down into saying things like, well, you need to return samples. You need to curate those samples. You need these types of measurements, things that we can actually go and work on. This is just you don't need to read this in detail, but just showing, so a single objective breaks down into many characteristics and needs, and then an even bigger subset of functions and use cases. And those functions and use cases, kind of the interpretation code for our engineering teams to start making decisions. So the next thing that comes along, what we really wanted to do is meet as many of the functions as we can broadly across multiple sets of objectives. So we need this data to help us make the right decisions about how to step forward. That is the yearly process we're now in. So this is our architecture approach. We have something called the architecture concept review. During the year, all of our analysis folks are looking at the trade space between these. We work very closely with the science mission director to make sure the right functions and the characteristics and needs and the use cases are documented. So this process occurs on a yearly basis and then feeds back into our architecture process on a yearly basis, and we document it in what's called the architecture definition document, and we release that product for public review. It gives a snapshot once a year of where we stand. The power of this is that we can then look through those functions and use cases, and we can identify places where functions are not being met. And this is what empowers our partnership, either with internationals or throughout the US. We can say, look, if you want to contribute something, here's a list of the functions that currently aren't being met, which means some of these objectives aren't being contributed to. In that way, we can start working with our partners so that if they want to help, we can point them in the right direction to fill the gaps that we have. So this is a really important part of our documentation that you can go read up on a year-to-year basis and understand what we're missing. I want to note that we think about our architecture in segments. Right now, we're in what's called human lunar return, which is the initial capabilities. Again, from the points we were discussing this morning, this is what I referred to as getting that foothold on the lunar surface. We've got to go land and get ourselves onto the surface so that we can start realizing the things farther downstream that will enable us to meet those bigger goals that we have. But if we don't get that landing and those first sets of landings in place for that foothold, and they slide to the right, that puts the entire strategy at risk. We have elements then that are the next things that come up. What we do is we assign functions to the elements. Just put this in here so that you can see the list of what they are that we have right now. And again, this is all in the public documentation that you can take a look at. But we started working with our international partners to identify what functions we're not meeting, and so they can then begin to give us contributions that will make a difference in the architecture strategy we're working. Do want to highlight one quick thing. The LTV is a good example. We understand mobility is a need. We did put out a call for companies to contribute to the LTV. We've been talking about this for a few years. 3 companies were identified earlier this year as being the companies that we will continue to mature their concepts, and they will have the right, similar to the way CLIPS is set up, to compete for the bid for the final LTV. Each one of them is different. They bring different capabilities and skills to the surface or to the discussion. but all of them will have the ability to carry science payloads. So our director at ESDMD is ensuring that the capability to do science is built into this, and we work with the other directorates to then advertise that science. So SMD is who you should look to when these opportunities come up to contribute the science to what we're doing. Just a QR code again, the documentation that we have out, the architecture definition document. Please read up on this. This is our way of communicating with the public, and it's what drives the opportunities that Sarah talked about in the prior presentation. I'm going to skip over that and go to this one real quick because Sarah brought up CAN 5. I just want to note, we get asked a lot, what does ESDMD need? We have it written down in CAN 4 right now, but we're going through an effort right now. We just met with all the PIs yesterday and talking about how to have better routine communication with you all, with this community, the survey community, to make sure that the work you're doing that's relevant to what we're doing, we have opportunities for that work to trace into the documents that we're developing. So we'll be contributing to CAN 5. I did want to introduce Dr. Kristen John over there. She's also here from our directorate, and she's going to be working to help pull that content together. And then we want to work with you on a more routine basis to make sure that the work you are doing traces into this. Last slide, Greg, sorry. Just wanted to highlight a success for us lately. Last week at the Michoud Assembly Facility, we had the core stage rollout for Artemis 2. I've said before, I really like when we can change our slides from artistic renditions into real slides of pictures of hardware, and rolling out the core stage was really a pretty big event for us. We're getting much closer to flying Artemis 2, which will be the first time we've flown astronauts around the moon in over 50 years. So, you know, I ask this all the time, but be patient with us. We are checking the boxes. We are moving along. We're going to get that foothold established on the moon so that we can go do that awesome science that you guys want to do. But we got to follow a process and stay on track as we move forward. Thank you for your time.